All right, working this one again. It always takes 2 tries. I don't get it. All right, problem 242. Probably turn on the problem statement. Oh man, problem statement is right there, and it must be hidden. I'm going to set the document camera to the bottom. There we go. Don't know why that was on the top, but that's okay. There's our problem. A tension member with a 50 by 100 millimeter rectangular cross section will be fabricated with a glued joint somewhere between 45 and 90 degrees at its midsection, as shown in Figure 2-42. If allowable stresses for the glue are 5 megapascals in tension and 3 megapascals in shear, determine the optimum angle for the joint. We'll start with that. What's the optimum angle for the joint? How are we going to solve that? Well, what do we know? We know sigma max is equal to 5 megapascals. And we know that shear max is equal to 3 megapascals. All right. They're asking us for theta, that angle phi and the safe load. Well, let's look at our equations a sec right here. Sorry, those are the wrong equations. Hold on one sec. I got to swap them out. Those are the equations we're looking for. So we have, if we start looking at our equation, we've got 2 equations and 2 unknowns. Let's get rid of our problem statement. I've got sigma n is equal to 5 megapascals is equal to P over 2a times 1 plus cosine of 2 theta. And I've got my shear N is equal to 3 megapascals is equal to P over 2a. There's a minus there. Sine of 2 theta. I can set those equal to each other. Well, I can't set them equal to each other. I guess I could, but that's really not the way to do it. I have to move it across, set them both equal to 0, mess around. What I can do is I can simply divide my shear equation by my normal stress equation, and I'm going to get 3/5, my megapascals canceled out, is equal to minus P over 2a times 1 plus cosine, on the top, it's sine of 2 theta divided by 1 plus cosine of 2 theta, right? No pen. No pen. Now, is that a nice equation to solve? I'm going to put that in parentheses. Actually, sorry. I got distracted. Just get rid of that whole equation. I'm going to get 3/5. My P over 2a, they cancel out. So I get a minus 1 times sine 2 theta over 1 plus cosine 2 theta. That's all I get. Now, can I solve? This is kind of ugly to solve. I am sure there's some trig identities that would help us out. I am sure there are. But I don't know them. So what I did was I went and I plotted it. I put my equation in. I can't show you the equation. I can't click on it and show you. But that's my equation, and I ran it, and I'm looking at all positive angles, and realistically, that isn't going to tell me anything. Well, why not? Well, sine in the first quadrant is positive, and cosine in the first quadrant is positive. So this is going to be sine over something between 0 and 1 divided by 1 plus something between 0 and 1. So that's always going to be positive, and yet my answer needs to be negative. So I have to look actually at the fourth quadrant. So instead of having that angle go up, it's going to go down. So it's going to be a negative angle where cosine is still positive, but now my sine is negative. And so when I when I put that in and I put negative angles in, you can see, yep, somewhere between 30 and 33 degrees. And I plotted it, but I don't know that really tells you anything. That plot really is not telling. I mean, you can see it's somewhere around 30 degrees is where I hit that 0.6, but it's in that neighborhood. I'm going to put theta is equal to approximately a minus 30 degrees. But yeah, it's close. It's close. Okay. What's the other thing I needed to know? What's the maximum safe load P for the member? Well, I have this equation up here, and now I know that 2 theta is equal to 60 degrees. So now I'm going to rewrite it. I'm going to go with another 5 megapascals is equal to P over 2A 1 plus cosine of 60 minus 60. All right. And they told me what A was. I didn't write it down, did I? A is equal to, I've got these dimensions at the top. It's 0.05 meters by 0.1 meters equals 0.005 meters squared, right? And then when I calculate that all out, substitute that in, calculate that out, P is equal to 33 kilonewtons. Sorry, can't see it. There you go. The area, 0.05 meters by 0.1 meters, 0.005. I'm going to get a load of 33 kilonewtons. There you go. Does that sound reasonable? I don't really have a sense for kilonewtons. And this problem is all... I don't have a sense. I can go back in and plug in everywhere and double check this. Double check what I was just circling. I could double check this by taking that load and putting it in here with my area and an angle and calculating that. But nah, it's not worth it. I'm good. I feel pretty good. I'll sleep tonight. Take care.